respiratory quotient or RQ value. A ratio of carbon dioxide released to oxygen absorbed is called respiratory quotient or RQ value. Okay, so this can be written as RQ is equal to volume of CO2 released over volume of O2 absorbed. Okay. So how do we calculate RQ value? Calculate RQ value for carbohydrates. It can be done in 3 steps. Step 1, write a balanced equation. That is C6H12O6 plus 6O2, and that gives us 6CO2 plus 6H2O. Okay, so this is the balanced equation for aerobic respiration of carbohydrates. This is balanced equilibrium. Now step 2 is write formula for RQ value. Write formula for RQ value. That is CO2 released over O2 absorbed. Okay. And step number 3 is put values of CO2 and O2 from equation to the formula. Okay. So you see, we have 6 carbon dioxide here, and we have 6 oxygen here. So we put value of carbon dioxide here from equation into the formula, and value of oxygen from equation to the formula. So that would be 6/6. So that would give us 1.0. So this is an RQ value for carbohydrates. RQ value does not have any units. So this is RQ value for carbohydrates. We can similarly calculate RQ value for proteins and fats. RQ values of fats and proteins. फैट्स की और की वैल्यू RQ value for fats is 0.7 and for proteins is 0.9. We can also calculate the RQ value for anaerobic respiration. Okay. For instance, we have C6H12O6, no oxygen used during anaerobic respiration, and if it is taking place in the muscles, so we will have 2 molecules of lactate produced, or if it is in the yeast cells, etc., so then we will have 2 molecules of carbon dioxide and 2 molecules of ethanol. Okay. So put these values into the formula. There are 2 carbon dioxide released, but no oxygen absorbed during this reaction. So RQ value will be 2/0. So that would give us infinite. Okay. As we discussed earlier, from RQ value, from knowing RQ value, we can get to know which substance is being used during respiration. And secondly, we could also get to know whether aerobic or anaerobic respiration is taking place. Okay. Now use of respirometer to calculate RQ value for germinating seeds. What is this respirometer? respirometer may be an instrument which has a syringe or a test tube with a long capillary tube attached with it, with the help of an airtight rubber bung. So this is an airtight bung. This is capillary tube. This may be a test tube or maybe a syringe. Okay. How do we use it? We take some measured mass of an organism and we put that into this respirometer. For example, we take 20 grams of germinating seeds, 20 grams of germinating seeds. Okay. We dip free end of the capillary tube. This is the free end of the capillary tube, and we dip it into an ink for a moment and take a small volume of ink into the capillary tube, and the level of this ink in the capillary tube is marked. Okay. Then we set this respirometer or place this respirometer on a horizontal surface or in a water bath at some suitable temperature. Okay. What will happen? These germinating seeds will respire and release carbon dioxide and absorb oxygen. If germinating seeds are using carbohydrates, like C6H12O6 plus 6O2, that would give us 6CO2 plus 6H2O. So you see, volume of CO2 released will be equal to the volume of O2 absorbed. So consequently, there won't be any change in the pressure inside the test tube or in the respirometer, and this dye will not move. So no movement in the movement. Okay. We repeat this experiment. We take 5 grams of soda lime, which is a carbon dioxide absorbent, and we repeat this experiment. So this is soda lime, and these are germinating seeds, the same as 20 grams. Okay, and the apparatus is placed at the same temperature. This placed at the same temperature on a water bath. So what will be now direction of this movement of the color dye? This color dye moves in this direction toward the germinating seeds. Why does it move towards the germinating seeds?
सर सोडा लाइम कार्बन डाइऑक्साइड एब्जॉर्ब कर लेता है और प्रेशर फर्क आता है.
Okay, oxygen is absorbed by the germinating seeds, and carbon dioxide is absorbed by the soda lime. So pressure inside the respirometer decreases. So air from outside that moves towards it, and that brings this dye to move toward the seeds. So this distance traveled may be noted as NX. Okay. We can calculate the volume of this movement of this color dye is due to an oxygen absorbed. So X represents the volume of oxygen absorbed. So volume of O2 absorbed will be equal to pi R square into X. Okay. Dye did not move in the first case. Okay. So it means that volume of oxygen absorbed is equal to the volume of carbon dioxide released. So from here, we have calculated the volume of oxygen absorbed. That will be equal to the volume of carbon dioxide absorbed. So we can calculate the RQ value by applying the formula and putting these values from here into the formula. So the RQ value will be 1 in this case. Okay. So volume of CO2 released is equal to volume of O2 absorbed. Let's see another case. If, for instance, we have a respirometer and we have 20 grams of seeds placed here. The dye has been taken up into the capillary tube and marked its level here. And this apparatus is placed at a suitable temperature in a water bath horizontally. And we assume that germinating seeds are respiring and using germinating seeds using fats during respiration rather than carbohydrates. अगर ये फैट्स यूज कर रहे हों तो क्या होगा? जैसे फॉर एग्जांपल for some fatty acid we can have C17 H35 O2 और अगर इसकी एरोबिक रेस्पिरेशन में हम इक्वेशन लिखें, बैलेंस्ड इक्वेशन, that will be plus oxygen, that would give us carbon dioxide plus water. If we balance this equation, it is 17 carbon dioxide and 23.75 oxygen absorbed. So if we calculate the RQ value for this, तो ये हमारे पास आएगी 17 divided by 23.75. If you calculate it, 7. Okay. So now look at this situation again. How many carbon dioxide are being released from these germinating seeds? 17.
Yes, sir.
And how many oxygen is being absorbed?
23.75.
23.75. So there is more oxygen being absorbed than carbon dioxide released. So this dye will move towards it. Okay.
Right side.
Towards the left side, towards the germinating seeds. Okay.
Okay, sir.
And this may be represented as Y. Same experiment, but now with soda lime placed in it. This is soda lime placed in it alongside the germinating seeds. Okay. The same mass of germinating seeds have been used in it. अब मुझे बताइए, what will be the direction of the movement of this dye? And will this move more distance than Y or less distance than Y?
And more distance than Y towards the left.
Yes. So this will travel more distance towards the germinating seeds. And this is represented as X. इसमें जितनी कार्बन डाइऑक्साइड रिलीज होगी, that will be absorbed by the soda lime, और जितनी ऑक्सीजन होगी इसके अंदर, that will be absorbed by the germinating seeds. Okay, so there will be more fall in pressure inside this test tube, so more distance will be traveled to the germinating seeds by this color dye. And this is due to, if we look at the volume of O2 absorbed, so this will be equal to pi r square into x. But now, what will be volume of CO2 released?
0.
How 0? If you look at both these apparatuses again, so here you see the dye in the first case has moved till this point, and dye in the second point has moved to this point. ये जो distance है, that the dye should have traveled in the first case too, which did not. Why it did not travel this distance? Maybe I can label
absence
A.
of soda lime.
Why?
Absence of the soda lime.
Yes, absence of soda lime. And what happened due to the absence of soda lime?
Carbon dioxide was
Carbon dioxide was released
not
here,
absorbed. Yeah.
which was not removed from the respirometer, or which was not absorbed by the soda lime. So it pushed this dye and prevented it from moving till this point. So this is actually volume of CO2. This much CO2 was released that pushed back the dye from moving the total distance to this point. You got that point? So volume of carbon dioxide will be
pi r squared by x minus y.
pi r square into x minus y. So now you have volume of carbon dioxide released and volume of oxygen absorbed. So you can calculate the RQ value. RQ value will be pi r square into x minus y over pi r square into x. So you can cancel out this pi r square, and the remaining will be x minus y over x. So this is how you can calculate the RQ value of germinating seeds. Is it okay?